Now, welcome to Emilac Online Tutorial. Let's look at this question. In the figure OQRS is a quadrant of a circle, which means it's a quarter of a circle of center O. This is the center. Now, OXRT is a rectangle 16 centimeter by 12 centimeter, which implies this will be 16 centimeter and 12 centimeter. Now, because this is length times breadth, so the length has the highest, the longest sides. Okay, now calculate the radius of the circle. Now we are told to calculate from here to this part. Okay, take note that we are told that this is a quadrant of a circle, which is a quarter of a circle. Let's assume that this is a circle. Now share it into 4, so it means that the whole of this is one part of this. Let me assume I draw it again. Okay, so this is what you have. Okay, now this is your 16 centimeter and this is your 12 centimeter. Okay, and we are told to calculate this radius. Okay, now radius we know is the point from the center of the circle to any part at the circumference. Now for us to get the radius, now you have to look at it very well. Okay, now look at this point and look at this edge. Now if we draw, now you see that this line, which is the diagonal of the rectangle, is the same as the radius of the circle, right? Now if that is true, so it implies here, okay, now we can now bring out that diagram. Okay, so here you have 16. So because here is 16, automatically here will become 16. So here is 16 centimeter and here is 12 centimeter. Now looking at this, now it means we have here radius. Let me put it as big radius. Okay, so with this now we can use a Pythagoras theorem, which is hypotenuse square equals opposite square plus adjacent square. Okay, now this is our hypotenuse, this is our opposite, and this is our adjacent. To this end we can say h square, that is r square rather, our opposite, that will be 16 square plus 12 square. So here you have r square. Now 16 square should give us 256 now plus 144. Okay, and r square here will then give us adding this will be 0. 6 plus 4 10, remainder 1. 5 plus 4 is 9 plus 1 10. Now 3 plus 1 is 2 plus 1 is 3 plus 1 4. So r will now be the square root of 400, which will give us 20 centimeter. So automatically here the radius is now what, 20 centimeter. Now we are told to find the area of the shaded portion. Now looking at this diagram here, you attest that it's also a sector of a circle, right? So if this is sector of a circle, now for us to get this area of shaded portion, it means we have to calculate the area of the sector, now subtract the area of the rectangle away from the sector. So there we have the area of the shaded portion. Now to this end, we can say shaded portion will now be area of sector then minus area of rectangle. Okay, so to this end, area of the sector is theta all over 360 times pi r square, then minus length times what, breadth. Okay, and we know that from here now we can also attest that this is 90, this is 90, this is 90, and this is what, 90. Since this part is a quarter of a circle and the circle is what, 360 divided by 4, that will give us what, 90. So we now have 90 all over 360 then times 22 all over 7 times our radius already is gotten as 20. That'll be 20 times 20, then minus length, which is 16 rather, times 12. Okay, so to this end, 90 here 1, 90 here 4. Now 2 here 2, 2 here 11, 2 here 1, 2 here, then 10. So we are left with 11 times 10 times 20 all over 7, then minus 16 times 12, which should give us 192. Now the whole of this on the right hand side will give us 11 times 10 times 20. That will be 2200 divided by 7. Now divided by 7, this should give us 314 points, approximately 3. Then minus 192. So this will give us 122.28. Now approximately away total. Okay, so approximately, let's say 122.3 area. So that will be centimeter, right? Centimeter square. Alright, this is the final answer. And if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you and God bless you.